This is a detailed, one-hour video presentation about configurable air transports, called CATs. They are a family of advanced multi-mission airlifters for military and, likely, civil, and commercial use. An earlier version of this presentation was made at the 2006 Airlift Tanker Association Conference. In 2016, the Air Force Secretary discussed the use of an Arsenal plane to increase the Air Force's warfighting capability. While this was originally expected to be a modified existing airframe, a clean sheet design is now being considered. The CAT concept provides the ability for true Arsenal plane capabilities along with many other important peacetime and warfighting capabilities. The CAT concept involves three aircraft: a strategic CAT, a theater CAT, and a tactical CAT. The strategic CAT is a tanker in the class of the KC-10. Able to carry up to 3 cargo modules, each the size of a C-130 fuselage, it also is an airlifter that can also refuel other aircraft at the same time. Finally, with specialized modules, strategic CATs can perform a variety of airborne military missions. The smaller theater CAT is also a tanker, in the class of the KC-46. It can carry 1 cargo module. And, like the strategic CAT, it can also carry the same specialized air power modules. The final concept is a large, tactical tilt rotor, capable of carrying the same modules. The following 12-minute video, created in 2006, provides an overview of the design and capabilities of the strategic and theater CAT concepts.
The nature of modern warfare is constantly changing, and air mobility continues to grow in importance, providing critical deployment, sustainment, and other operational support for the U.S. and its allies. Air mobility modernization began with the acquisition of the C-17 and continues with the C-5M, the C-130J, and the C-130 AMP programs. Now, the Air Force looks to modernize its air refueling capability, currently provided by a fleet of over 400 KC-135s. In the 1980s, the Air Force took a conservative approach to expanding its air refueling capability by modifying commercial aircraft into air refuelers. We have learned much about air mobility capabilities and needs over the past 50 years. As the Air Force looks to update the capability currently provided by the KC-135 fleet, now is the time to explore the full spectrum of possible solutions that could provide effective and flexible air refueling and airlift well into the 21st century. The Configurable Air Transport, or CAT, is such a concept. Through its ability to carry modules, the CAT is a true multi-mission aircraft responsive to the air mobility challenges of the 21st century. While the CAT is an innovative aircraft concept, it is built on proven principles that have been in use for decades. The CAT utilizes the same principles that work so successfully in the civilian realm with containerized shipping systems. Sea, rail, and truck transportation networks have become highly interlinked through the use of standardized intermodal containers. In addition to the increase in speed and efficiency of moving cargo from origin to destination, containerized shipping also increases the utilization rates and therefore the efficiency and effectiveness of the transport vehicles themselves. The key to the success of modern shipping networks has been the standardized intermodal container and the vehicles that were designed to carry them. And this same success could be realized in today's military airlift through the use of airborne modules, enabling fast, secure, and efficient transport of cargo, vehicles, and personnel, as well as their possible use in a wide range of other air power and airborne support missions. Preliminary studies of module and aircraft configurations indicate that a module slightly wider and taller, but about the same length as a C-130 fuselage, could carry most Army air mobile combat vehicles and associated equipment. Specifically, the module will be sized to carry 6 463L pallets, or current and future Army air mobile combat vehicles. The modules are designed for independent ground mobility on the ramp. The self-height adjustment of the modules enables quick loading from the ground, standard loading docks, and flatbed trucks. Major General Gavin, commander of the Army 82nd Airborne Division during World War II, authored a history of airborne operations that included a look at desirable future capabilities. Recognizing that increasing the value of air mobile operations was closely tied to the capabilities of their air transport vehicles, General Gavin advocated modularized cargo containers and module-carrying aircraft. This idea was picked up by Fairchild, then building the C-119 theater transport for the Air Force. To see if a module-carrying transport was practical, Fairchild built 2 prototype XC-120s based on the C-119. In the 1930s, U.S. aircraft designer Jack Northrop pioneered a revolutionary aircraft design called the flying wing. 50 years later, in the 1980s, the Air Force used the flying wing idea to develop the revolutionary B-2 strategic bomber. Now, NASA and AFRL are investigating the next revolution in transport design, a version of the flying wing called the blended wing body, or BWB, that is aerodynamically and structurally more efficient than traditional aircraft designs. The module-carrying version of the BWB, referred to as the Configurable Air Transport, or CAT, provides a highly versatile, time-resilient solution with the capability to provide strategic air refueling, global reach air cargo transport, global reach air power projection, and persistent airborne surveillance. This strategic CAT tanker could be complemented by a theater CAT tanker, capable of providing the theater commander with comparable mission capabilities for dedicated air power, theater air refueling, and dedicated theater surveillance using the same modules. While the C-17 and modernized C-5 would still provide critical oversize and heavy cargo transport, a fleet of new strategic and theater CATs could provide substantial air cargo mission capabilities to efficiently deploy and sustain air and land tactical forces, in addition to their core mission of strategic and theater air refueling.
And keep it going left. X8.
An example mission would be to rapidly air deploy an Army on-alert air mobile combat brigade from CONUS to forward air bases. Being on alert, the brigade's combat equipment and vehicles would be loaded onto Army-owned modules. Road transportable, these modules would be moved to the adjacent Air Force base or Army airfield for pickup. The United States Transportation Command, working in conjunction with the Air Force Air Mobility Command, would plan the air bridge to efficiently move the Army brigade to forward air bases. As the modules would have already been checked to ensure that the cargo is properly secured and within allowable limits of weight and balance, they could be moved directly to the ramp for pickup. Air Mobility Command strategic CATs would arrive, refuel if necessary, pick up the Army modules, and depart for regional or allied air bases near the theater of operations. On arriving at the regional base, the strategic CATs would taxi to a designated location on the ramp, detach the modules, and depart, all in a matter of minutes. Almost immediately, the modules could be directed into position for pickup by the theater cats, or parked away from the area of ongoing operations for temporary secure and protected storage until moved forward. By using cargo modules, the traditional en route unloading, sorting, storage, and reloading of palletized cargo and vehicles would be replaced by the efficient movement of material and vehicles from strategic to theater air mobility systems, shaving hours and possibly even days from traditional deployment timelines. Further, this use of airborne modules would virtually eliminate en route delays due to MOG constraints, limited material handling equipment or personnel, weather, or a lack of secure temporary cargo storage. Literally within minutes of arrival on the strategic CATs, the Army modules could be on their way to dispersed forward operating bases. Basic Expeditionary Airfield Resources, or BEAR bases, are used to temporarily station expeditionary air forces and disembark mobile land forces. BEAR-based versions of the airborne cargo modules could be used to store, transport, house, power, defend, and sustain the expeditionary forces using air-transportable, environmentally controlled facilities that provide improved ballistic, chemical, and biological protection compared with conventional tent facilities. In an era of increasing technology utilization at all levels of military operations, BEAR-based modules provide a new means to package, deploy, and sustain high-tech equipped expeditionary forces. For example, hospital modules could provide full emergency diagnostic, surgery, and critical care facilities. Maintenance facilities could provide problem identification and resolution capabilities while being fully electronically linked into reachback supply and expertise networks. Finally, BEAR-based modules could be readily adapted to quickly add new warfighting capabilities such as UAV and near space system control centers and new base defensive capabilities. As the Air Force considers how best to modernize its air refueling capabilities, technology and design innovation through module-carrying aircraft could establish comparable world-leading air mobility capabilities. This would sustain critical strategic and theater air refueling capabilities and add new airlift capacity and new expeditionary forces, deployment, sustainment, airborne support, and air power projection capabilities. Almost 40 years ago, the C-5 Galaxy introduced a new era of air mobility. Today, the innovative design application of existing and emerging aeronautical technologies could enable configurable air transports to modernize air mobility to meet the changing needs of the 21st century.
Development of the family of CAT concepts will provide the American aerospace industry with the opportunity to introduce new, highly advanced aerodynamic, propulsion, materials, and fabrication technologies into America's aerospace industrial base. Examples include alternative green fuels and electric-powered aircraft, advanced materials such as graphene, advanced manufacturing methods such as 3D printing, and the use of AI for co-piloting and mission execution. These topics are covered in this presentation.
The strategic and theater CATs are tankers. This first part discusses their performance as tankers. The need for tankers arose after World War II. The KC-97, called the Stratofreighter, was one of the Air Force's early tankers. Today, the Air Force has two operational tankers. The KC-135R, on the left, was acquired in the 1950s, over a half-century ago. It has been substantially upgraded with, for example, new engines. The KC-10A, on the right, is a modified commercial airliner acquired in the 1980s. However, it will soon be retired. This chart shows the fuel offload capabilities of these two tankers as a function of the mission radius. For example, at a mission radius of 2,000 nautical miles, the KC-10 is capable of offloading about 170,000 pounds of jet fuel. The Air Force began a decades-long process of modernizing its tankers in the early 2000s. The strategic and theater CAT concepts could meet the needs of the KC-Y and KC-Z tankers. Please pause this video to examine this chart in detail. Currently, the Air Force is acquiring modified Boeing 767 airliners as the new KC-46A tanker, shown on the right. It will replace some older KC-135s. Serial production of this tanker will not begin for several years. We see that the offload capabilities of the new KC-46A are similar to the older KC-135. According to the Air Force Tanker Modernization Roadmap, the future KC-Y tanker acquisition is intended to replace the retiring KC-10A. Since its first tankers, the Air Force has acquired tankers based on existing aircraft designs. The Air Force has followed this paradigm in acquiring the KC-46A. The CAT concept introduces a new modular paradigm, with its strategic and theater tankers having true multi-mission capabilities. The strategic CAT uses a design called a blended wing body, essentially a flying wing design. The strategic CAT concept shown in this presentation is a sized aircraft with these characteristics. This analysis was done by the Aircraft Conceptual Design Group at Wright-Patterson Air Force Base. The Air Force uses tankers when moving its fighters, such as the F-22 shown in this photograph, and bombers to forward bases. To size the strategic CAT, the length of the Great Circle routes between main continental U.S. and forward bases were examined. The Great Circle distance from Guam to Diego Garcia is 4,500 nautical miles. This distance, with a 600 nautical mile margin, was selected as the sizing point for the strategic CAT. The 600 nautical mile margin represents weather and overflight margins. These next two charts show the details used in estimating the strategic CAT fuel offload needed for this F-22 ferry mission. This chart compares the offload capacity of the KC-10A, with a takeoff gross weight of 590,000 pounds, with a strategic CAT with a takeoff gross weight of 751,000 pounds. Strategic CATs have the range and offload capacity to support global strategic power projection missions. Now, let's look at the tanker capabilities of the theater CAT. Here are the tanker characteristics of the sized theater CAT. Like the strategic CAT, The Theater Cat can refuel using both the Air Force flying boom and the Navy's probe and drogue. Here is the comparison of the Theater Cat with the KC-135R and the KC-46A for missions out to 2,500 nautical miles. Note that the Theater Cat would augment the KC-46A by giving the theater commander a deployable tanker with substantial multi-mission capabilities.
This part discusses the conceptual design of the common cabin used in these two aircraft. To enhance their multi-mission capabilities, both the strategic and theater cats would be designed for extended airborne missions, perhaps up to 5 days. The cabins of the two aircraft would likely be similar, if not nearly identical in arrangement. The cabin is designed for 4 mission workstations and 12 passengers. The passenger seats also provide crew rest accommodations for extended missions. Access to the module, being carried by the Theater Cat, is provided at the aft of the cabin.
This part examines the airlift performance of the strategic and theater cats. In the 1950s, the Air Force adopted a standardized cargo pallet, referred to as a 463L pallet, to improve air cargo transportation efficiencies. Air Force airlift aircraft incorporate provisions to load and restrain these pallets during flight. Besides the C-17, the KC-46A and the KC-10A have airlift capabilities that will be used for comparison. Shipping by container has revolutionized cargo transport and management. Containers speed loading and unloading, provide sheltered storage with security, and enable multi-mode transport. Specialized containers provide missionized capabilities, while retaining the benefits of using containers with common interfaces. The container revolution has not yet reached military airlift. To move containers by military airlift, they must be attached to 463L pallets. This is a time-consuming process. CATs bring the benefits of shipping containers to airlift. General James "Jumpin' Jim" Gavin commanded the 82nd Airborne into Normandy. After the war he published the book, Airborne Warfare. In the book, General Gavin proposed the use of airborne modules. After World War II, the C-119 was built for theater airlift. A modified C-119, called the XC-120, was built to test Gavin's idea of a module carrying airlifter.
At Hagerstown, Maryland, the U.S. Air Force demonstrates its latest cargo plane. This is the Fairchild XC-120, a pack carrier plane with a detachable fuselage. Doors are designed like clamshells. Cargo capacity is 20,000 pounds. It carries 64 combat-equipped troops or 36 litter patients with 4 attendants. The pack has detachable wheels. 4 electric drum hoists raise and lower the pack from the carrier. A central control operates the release and locking mechanism, and the pack lowers to its own wheels. Then the hoist lines are detached. The five-man crew of the carrier consists of pilot, co-pilot, radio operator, navigator, and engineer. When the pack is separated from the carrier, it is easily towed away. This pack can be used to house various types of shops, headquarters units, emergency hospitals, weather stations. It can also be converted into a tanker for carrying fuel. Ball socket connections lock the pack to the carrier. A rubber tubing seals pack to carrier by compressed air. On the carrier, the four ball socket locks operate simultaneously. The carrier is powered by two Pratt & Whitney engines with reversible pitch propellers. The maximum speed is 250 miles per hour. The ceiling is 25,000 feet. The landing gear consists of four retractable dual wheel units. It's electrically operated, and the main or rear wheels have brakes. This airplane opens a new field for aviation. The cargo pack is to aircraft what the trailer is to highway trucks.
The C-130 is the military's theater airlifter. It was first acquired in the 1950s. It takes about 2 hours to onload or offload cargo from the C-130. It can carry up to 42,000 pounds of cargo. The CAT module is about the same length as the C-130 fuselage, but a little taller and wider. Like the C-130H or J models, the CAT module can carry 6463L pallets. The average cargo load would be about 40,000 pounds, while the maximum would be 52,600 pounds. We will compare the strategic CAT's airlift performance, in terms of payload versus range, against these three airlifters. Starting with the strategic CAT carrying up to 3 modules, each with the maximum of 52,600 pounds. These are the results for the average 40,000-pound module loads. While the C-5 and C-17 would still be used for oversize payloads. The strategic CAT would extend their service lives, while also providing tanker and multi-mission capabilities, including being a true arsenal plane. Now, let's compare the C-130 with the theater CAT carrying a single module. Here are the payload range curves for the C-130s. The theater CAT has modestly better payload range performance than all C-130 versions. Let's summarize the CAT airlift capabilities.
With all of the emphasis on the CAT's use of modules, let's go over their key design characteristics. Most modules would have solar arrays to keep key avionics and communication capabilities powered, while also powering the drive motors, ramps, etc. A key feature of the module is that loading and unloading can be done off the flight line, reducing congestion. Wheeled and tracked vehicles can be loaded directly, while loading docks can be used to load conventional cargo. Loaded modules, already weight and balance checked, can be towed to a secure holding area to await loading onto CATs. To prepare for loading, the modules, under their own power, are directed to the flight line. Where they are picked up by a designated CAT. It's possible that the CAT would depart within 30 minutes of arriving without needing to stop its engines. When modules must be moved forward to smaller airfields, theater CATs self-deploy to regional bases. The strategic CATs deliver the modules to the regional bases. Engines running, the modules are released on the flight line and the strategic CAT leaves to minimize congestion. Under their own power, the modules are moved to await the arrival of the theater CATs. The modules provide a basic level of security and protection of the cargo. The theater CATs pick up modules on the flight line without the need to unload and reload aircraft. The theater CATs quickly depart to transport the modules forward. With its 2,000 nautical mile range, the theater CATs can deliver modules quickly worldwide. Tactical tilt rotor CATs can then move the modules the final miles to where needed. Literally, the CATs can pick up a module from almost anywhere in the world and deliver that module almost anywhere it is needed, quickly and efficiently, while keeping the cargo secure.
Having mentioned the tactical tilt rotor CAT, let's briefly discuss this concept. The tactical CAT would essentially be a C-130 with a vertical takeoff and landing capability. A helicopter of this size has been studied. NASA studied such an aircraft as part of its large civil tilt rotor study. Note that the payload was about 20,000 pounds. Unlike the strategic and theater CATs, which were sized aircraft, the tiltrotor CAT is still a notional design. The intent is to show how a module would be integrated. These are notional weight and performance values. Advances in electric-powered aircraft could be incorporated into this design. Besides CAT modules, the tactical CAT would also be able to transport other heavy payloads. As you have probably noted, the CATs use a long landing gear to enable the modules to be carried. The B-58 was a Mach 2 supersonic bomber developed in the 1950s. It used a large centerline fuel pod that would be jettisoned. The B-58 required long landing gear to enable the fuel pod to be carried. The CATs use this proven landing gear geometry to provide the height needed to load and unload the modules. A substantial advantage of using modules is the ability to missionize modules to replace retiring aircraft or add new capabilities, not just for the military but also for civil and commercial uses. Moving from specialized aircraft to missionized modules on strategic and theater CATs would substantially reduce maintenance and flight crew training costs, while also enabling a diversity of missions that is unaffordable when using special-purpose aircraft. In lower threat environments or from standoff distances, CATs can perform many airpower missions when carrying combat modules. Loading munitions and servicing the combat modules would not require the presence of the CAT aircraft. Munition modules, equipped with rotary launchers, can be used. Of course, the same combat modules that can be carried on the strategic CATs can also be carried on the theater CATs. This chart shows the mission radius with 12 and 6 2,000-pound weapons. These next three maps show the operating radius, with and without air refueling, with a 24,000-pound weapon load. And, if the Air Force does retire the B-1, then, the theater CAT, with its large payload capability, long endurance, and its design for persistent missions would be a replacement. For ground forces support, mine laying, and other non-nuclear missions that the B-1 undertook. Maintaining unique combat capabilities, such as modified electronic warfare aircraft, are increasingly cost-prohibitive. Strategic and theater CATs could carry a much wider range of such special-purpose modules, without costly airframe modification programs. Combat drones are increasingly being used by the U.S. military. However, land and sea forward basing is increasingly difficult, as the anti-access missile threat continues to grow. Using missionized CAT modules, armed combat drones can be air-based, operating from loitering strategic CATs. This video, developed using an earlier strategic CAT design, illustrates how such a combat drone could be rearmed and refueled using a drone tender module. Let's look at a scenario to illustrate how air-based combat drones could be used. Using the Alaska landmass as an example, the mission is to air-base combat drones 250 nautical miles off the coast and conduct intelligence, surveillance, and strike missions. Carrier-based F-35s would provide protective combat air patrols. The drone is envisioned as a high-altitude, Mach 3.5 unmanned vehicle with these design parameters, based on a preliminary analysis. This would be a typical flight path for the drone. The drone would use both radar and electro-optical sensors to gather intelligence and conduct surveillance. This is the baseline drone mission profile. The drone conducts a U-shaped mission covering 1,820 nautical miles. Along this flight path, the sensors can record over 9,000 square miles of surveillance data within a broad area of nearly 600,000 square miles. The total mission time would be about 60 minutes. Here is a summary of the potential of a single strategic CAT equipped with 3 drone tender modules. In total, 5 strategic CATs would be required for 24 hours of operation. 2 CATs, separated by up to 1,800 miles, could also pass the drones between them. Of course, F-35s would also be used for attacking targets identified by the drones. CATs equipped with combat drone tenders illustrate the value of sustained airborne operations. Routine long-duration missions are now being conducted. To provide persistent air power capabilities, the strategic and theater CATs would be designed for 5-day missions. Strategic and theater CATs would provide long-range air power without requiring the use of nuclear-capable bombers. History shows that the warning time of major military crises is often short or non-existent. Yet, the Air Force must be able to equipping theater and strategic CATs with offensive and defensive combat modules enables air battle groups to be deployed quickly. Here is a notional CAT air battle group. Finally, as there will always be the need for dedicated special mission aircraft, the strategic CAT has substantial internal volume available for such uses.
We will now focus on understanding the operational benefits of using modules, starting with cargo loading and unloading. During times of crisis, the aircraft utilization rate determines how many aircraft and how much time is needed to move cargo forward. Passenger airliners have turnaround times under 1 hour. This is done to minimize the needed fleet size and required ramp space, and maximize revenue. Unlike flight crews, aircraft do not need to rest. In times of crisis, high utilization rates are needed. The key to increasing the utilization rate, the time actually flying, is to load and unload cargo faster. Due to their design, converted commercial airliners take longer to load and unload cargo. For military cargo aircraft, loading and unloading is done on the ramp, creating congestion and often requiring specialized equipment. Specialized cargo handling equipment must often be transported first to unload pallets. Traditional loading docks are designed to enable quick loading and unloading of truck trailers. CAT modules can be backed right up to standard height loading docks and loaded just like a truck trailer. This enables module loads to be assembled, checked, and secured until loaded onto a module, keeping the cargo protected and secure until it's unloaded at its final destination. The United States responds to a natural disaster in distant Nepal. For such emergencies, preloaded modules would be stockpiled at U.S. and Allied bases around the world. This would speed the response to emergencies when time is critical. The mission is to deploy 800 tons of supplies from Wheeler-Sac Army Airfield in New York to Nepal by way of Spain and the United Arab Emirates in the Persian Gulf. The C-17, KC-46A, and strategic CAT will be compared to assess how long it takes to deliver the 800 tons. The round trip requires 5 ground refuelings, 1 at Wheeler-Sac, 2 outbound and 2 on the return. There is no refueling in Nepal. Here are the cases that will be compared: the number of pallet positions on each aircraft, and the average total payload expressed in tons. These are the number of missions required to complete the delivery. In Nepal, due to expected airport congestion, only 1 aircraft can be on the ground. It must unload and depart before the next aircraft arrives. Here are the details of the C-17 analysis. Slightly more than 3 days would be required to complete the delivery. Please pause the video to examine the results. Here are the results for the KC-46A analysis. Almost 6 days would be needed to complete the delivery. For the first CAT analysis, 2 modules will be used. Here are the KC-46A and C-17 offload times. The XC-120 experimental aircraft showed, 70 years ago, that detaching the module can be done expeditiously. This video, developed for an earlier version of the strategic CAT with a single large module, illustrates how the modules will be quickly detached. Once the modules are released, as the CAT taxis to depart, under their own power, the modules would be guided off the flight line for storage or unloading. For this analysis, a conservative offload time of 30 minutes and a load time of 60 minutes are used. Here are the results for the 2-module strategic CAT analysis. The final delivery would be completed in less than 2 days. For the second CAT analysis, 3 modules will be used. Also, air refueling will be used to fly directly to and from Nepal using the same air route. Here are the results for the 3-module strategic CAT analysis. The final delivery would be completed in just over 1 day. Now, we can compare the results. The extended range C-17 would require 3 days. The KC-46A would take nearly 6 days. With using just 2 modules, the strategic CAT would take about a day and a half. Finally, with using 3 modules and air refueling to speed delivery, the strategic CAT would take slightly over 1 day. Air refueling could also be used when intermediate bases were not immediately available. With either 2 or 3 modules, the strategic CAT outperforms the C-17 and the KC-46A, especially the latter. Of course, this advantage would also apply to the rapid deployment of U.S. combat forces.
In this part, we will explore examples of the use of missionized CAT modules. The CAT modules have substantial internal volume that can be used for missionized purposes. The usable flat floor area is about 500 square feet. Just as with conventional cargo aircraft, standard CAT modules can be configured for general patient transfer, such as shown here. All patients can be preloaded in the module prior to being connected to the aircraft, preventing the aircraft from being on the ramp during the time the patients are being loaded and prepared for flight. The use of medical evacuation modules provides an increased level of medical support without permanently committing transport aircraft to this mission. These modules would be designed to transport critical care patients, such as patients with burns and battle injuries, and patients requiring specialized isolation such as those exposed to chemical, biological, or nuclear agents. In such cases, the module would be isolated from the CAT and the entire module can be cleaned and sterilized. And by using the tactical CAT, such modules can be transported forward to where they are needed. CAT modules enable humanitarian relief modules to be owned, maintained, and staffed by non-military organizations, such as the Red Cross. One way to think of all of this is that the modules are apps being used by a common set of aircraft. These next 2 charts summarize the advantages of using modules.
In Part 10, the use of missionized modules for building and supporting advanced forward bases is discussed. U.S. military forces, in times of crisis, require the construction of temporary advanced bases. 70 years ago, General Gavin anticipated the use of air-delivered modules for building and supplying forward bases. With many expeditionary missions lasting months, even years, CAT modules enable more secure bases to be quickly built. This presentation introduced and explained the benefits that will arise from a family of new aircraft capable of carrying interchangeable modules. Here are the primary benefits.
Thank you for watching this presentation.